Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. Today we are going to be taking a look at control rig, and specifically we're going to take a look at character lookats actually. And the idea here is to be able to make it so that our enemies and our NPCs can look at our player no matter where they go, whatever animation they're playing and wherever the player is, so that we can kind of increase that connection that we have between our players and our NPCs in our game. My name is Kevin. As always, if you like what we're doing on the channel, there's lots of ways to support what's going on. We've got the tips down below. We have Patreon. We have, if you are experienced in any particular field as it pertains to real-time development of any kind, hop in Discord, help answer questions is great. And as always, spreading the word is awesome. So before we get started, I thought it would be cool because we're going to be doing this with two different methods. One is a little bit more of the standard thing that you see around, and the second one is an idea I had to kind of clean that up and spruce it up a little bit, something different. But let's hop in and take a look at what we've got going on in Unreal as an example of what we're talking about. Don't laugh at my manis. They're fun. Okay, so here we go. Let's take a look. So here we are in Unreal Engine, and what I have done is I've added glowing eyes to all my manis, which is why I said don't laugh at my manis. The reason I've done that is because I wanted to make it a little bit more obvious where they're looking. And you'll notice that every single one of them is looking right at me. And wherever I go, they follow, which is kind of cool and also potentially kind of eerie. And you'll notice that there's a bit of a fall off that happens between their upper bodies, their lower bodies. And as I get closer, you know, this guy looks down at me and so on. So and it's actually really kind of cool when we get up and we you know, as we walk around close in, they will just follow me around wherever I go. And right now they're playing their idols. Okay, so that is what we're working on today. We're going to be taking a look at our lookat, and let's get started with method one. Here we go. Okay, so what we need here is we need a control rig to start with, and you can see we have a ton here because we've been doing so many tutorials on this. But let's just right click and create a control rig, and we're going to call this control rig Mani, and this is going to be look at method A. Okay, now that we've done that, let's go ahead and open this up. And the general gist is what we want to do, I'll talk this over here so you all can see it, and also make this a little bit more readable for you all. So what we want to do is we want to basically have our character look at an item or a transform in space, and we want the rotations basically to fall off. So if the head follows at 100%, the neck is 90, the lower neck is 80, 70, 60, 50, all the way down the spine with a little bit of offset. So that's kind of the general gist of what we're going for. And in order to do that, we do need a little bit of hierarchy to work with, but the joints specifically, or the bones that we're going to be working with, are basically, for now, our spine through our head. So I'm going to grab these, and I'm going to start by creating an item array because we're going to be using this a lot. Now, I'm not even going to start with our forward solve. I'm going to start with our construction script, because what I want to do is I want to build a hierarchy of controls that I can use to, one, visualize, and two, for method two, I think it'll be easier to use those with their differences and stuff. So let's go ahead and do this. So first we need a construction script, construction event. And what we are going to do is we need a couple things. We need an object to look at. So first, let's create a control. And this control, or spawn a control. And we are going to name this control. This is going to be our, let's call this lookat. Okay. And we do need to give it an initial value. So let's make a transform. Actually, let's just go ahead and let's see, where do we want to put this? We want to put this, actually, let's get the transform of the head bone. So by default, we want this in front of our head. Okay, so let's get the transform, and the transform we're going to be getting for now, this is coming in later, don't worry about this yet. I'm going to make this a little smaller for now, just so we have some room to work, because this is where all the important stuff happens. Okay, So we're going to get the transform of a bone. In this case, the bone we're going to use is the head bone because we want this to appear straight in front of the head. And I'm going to get that in global space, and I'm going to get the initial value. And what I want to do is I want to add to that, let's see here, I'm going to multiply that. With transforms, you don't add, you multiply. So I'm going to multiply that, and I'm going to multiply that by a translation in, let's see, what axis is this? This is Y. So let's try 100. Let's just see if we can get that to show up where we want it. So this is going to be our initial value. This is going to be in global space, and we have that. And look at that. We have a transform in front of our character's face, right in front of our character's face. That's great. But I'm actually going to call this transform look at in world space. So this is our world space look at. Now I'm going to create a couple of offsets and make some changes here, because what we're going to have is we're going to be testing, so we're going to be moving around a control, and then we're also going to be having we're going to be having an offset control as well. So that's our look at in world space. And then let's go ahead and set some shape settings here. I'm going to change these to be, well, can I just pick this and shows up? Yes, it does. So let's go ahead and make this yellow so it's central. And then the shape is going to be, I think it's box it's called. Nope, not called box. So let's click on, let's reset this to default. And under our shape, we can click on our defaults. I believe it's called, what's it called? Sphere, wedge, triangle, box. Oh, it's called box thick. There we go. So I like to use square objects for things that translate. It's just the way I work. And I'm going to break that rule here in a second, but that's okay. So here we go. We've got our box. Now we need a couple other things. Let's spawn another control. This one is going to be parented to the control we just made. And its transform is going to be in local space because we want it to be in the exact same space. I'm going to change our settings. I'm going to change this to a sphere thick. We can do sphere thick, and you'll see it appear right inside there. That's perfect. This one I am going to call the look at control. And then finally, we're going to create one more, and this one is going to be a chest offset. Now, one of these is redundant probably, but I still like to have it just in case I need it. This is going to be our look at chest offset control. Probably, I guess it would probably be better if we called these things something more like this, just kind of to follow more of a convention. Control, for example. All right, but I do want to change the size of this one slightly. And the reason being is because I want to be able to see it relative to, so we can see it moving. So I'm going to just scale this one down to 0.8, for example. Let's go 0.8, and I might change the color slightly, just so it's a little bit more apparent which one's which. All right, so, and we also want to parent this in. We can close down our shape stuff to save our settings, just to save space. All right, so we have our three controls. These three represent what our character is looking at. Fortunately, it's right in front of his face, so it's easy to visualize. So let's compile and save often. I cannot express this. The number of times I am crashing with all this new cool stuff is insane. So now that we have all of our controls, now we need to set up a series of controls for our spine and our head and neck. And that's where, let's move this down. That's where this array is going to come in. And what I'm going to do is I'm going to do this in a sequence. So let's just go ahead and I'm going to hold S and left click, and that's going to create a sequence node for me. And let's plug into the sequence. And the first thing we're going to do is create our lookats. And now the second thing we're going to do is for each of these, I want to create two controls that are aligned to each of the bones. And it's going to be very easy to visualize when we're done, but basically we're going to go through the entire hierarchy. We're going to make a control, make another control that's the child. We're going to turn it into an arrow so that we can just see what's going on visually. All right, so to do that, we need a for loop. So for each of these, what we are going to do is, you guessed it, we're going to spawn a control. Now, the control itself is going to be named a little bit differently. So we're going to take our element, and I'm going to create, remember I said 2 controls. So let's concat to the name of this. We're going to call this, the first one, the underbars ETR. That is our 0 transform rotate. Once again, I have not come up with a more succinct naming convention yet. It's just what I'm used to, so that's what I'm going with. The overall point of this control is it basically is meant to be there to represent, so that the control underneath it is all zeroed out. And I'm going to need another one. This one is going to be called the ATT node eventually. All right, so with these two, we're creating a control. It is going to be named look at. Now, the parent is a little bit different. We probably need a root control. We should make one. So actually, let's go back up here and make a root control and put that in. So hold on one second. So let's spawn one more control. This one, we're just going to call the root control. And let's make a default transform. Make a transform, because you have to fill in a value. So that is going to be our initial. It's going to be 0, and we will connect into this and to here. And this one, from a shape standpoint, we will go ahead and make this a circle thick. And I think it doesn't like circle thick. So let's see what's going on with our settings. No, circle thick is cool, man. Let's see here, hold on. Circle thick, okay. I don't know why it's showing, oh, it's showing a square down there. Okay, that's why. It's showing a square down at the bottom because we have our other control down here. So let me collapse this back down. Okay, so we have our root control now. I am going to color this a little bit more orange, I guess. Click OK. And then let's set our scale on this to be, let's say 10 across the board. Okay, so we have a root control. All right, the reason I made that quickly is because I want to parent this first control, the 0 transform rotate control that I'm calling it, to the control of our root. So here we go. This is going to get parented to our root. And then in addition to that, what we're also going to create, oh, and the initial values, we need to get our initial values. We're going to get the transform. So let's get the transform. In this case, this is going to be the transform of the bone in global space. And we could use initial, that's fine, but let's just go ahead and connect this into initial. And then the transform settings, let's change this to an arrow thick. And if we compile that and we change our scale, let's try a scale of, let's say 5. See how we do with that. Not 50. Okay, so let's compile that and save it just in case. So we have a bunch of arrows. They're kind of pointing the wrong way. So let's just adjust them. Now it's important here. We're adjusting the shape. We're not adjusting the transform. This is just the visual. So let's rotate this 90 degrees and let's flip it 180 degrees so they're pointing forward. Okay, so each of these arrows represents each of the joints in our spine and neck and head. Now I am going to change the X scale slightly. Let's try 2. That feels fine. Okay. And let's change our color as well. Reason being is because I would like to be able to, I guess we could leave it at that. We can just leave those yellow. Yellow is good for center controls. Okay, cool. So we now have our arrows. Perfect. Now we need our second set of arrows. Now, what we're going to do with that is we're just going to spawn a second set of arrows. The parent is going to be the arrow we just created, and we can put it in the exact same space or place, and it is going to be called the name that we just created over here. This is going to be our ATT. All right, so if we compile this, now this one I do want to make a slight change to. The reason being is I want to be able to see it. I want to be able to see it. So let's change a couple things about this one. We are going to let's change the color a little bit. Let's go a little bit more towards orange. We can do that. And then let's change our scale to be, you know what, let's scale down. our other one. So let's go 4 on our ZTR1 and 1.5. And let's compile that. All right, so we should see 2 arrows. We do. I do not see a big enough difference between these two. I want to be able to see it. So I am going to change this color to be even more orange. Okay, that's a little better. You know what? Maybe we'll just go to this bright blue. Simply because I want you all to be able to see it. The visuals of these controls are not important. What's important here is that you are able to see it for debugging. I do this a lot because I want to make sure I understand what is happening in my control rigs, and these can really help. So what you ultimately, you could use nulls, you can do whatever you want, but ultimately that is a good way to go. So once again, compile, save. So we have a root control, we have all of our spine controls, and if we zoom out, we also have our look at as well as our offsets. What's next? Well, we need to get into the actual work of the forward solve. So in order to do that, what we're going to do is basically we need our array again. So what we would like to do at this point, now that we have all of our controls set up, we need to start making it so that they actually aim at our look at and adjust some of our constraints and things like that. So let's dig into our forward solve. We may have missed something in our setup. We can come back to that in a minute, but for now, let's just dig into our forward solve. Okay, so in here, we're basically going to iterate over this so you can kind of see the progression as we go. But as per before, we do need a for loop. Let's go for each of these. And what we're going to do is for each of these, we are going to set the transform. And we're going to set the transform of, let's set transform. We're actually going to be setting the transform of our ZTR and ATTs to begin with. So I'm going to disconnect this, and we do need to bring that back. So let's concatenate. So we have everything. This way we have our bone, our underbar ZTR, and also our underbar ATT. That way we have access to everything. I say underbar all the time, underscore, that's what a lot of people call it, most people call it, but that's okay. So we're going to be setting the transform of, in this case, the item is going to be initially our ZTR. Why are we doing this? What we're doing this is for every frame, I want our controls to align up to where the spine is, so that they can aim at the look at from wherever the spine happens to be. So the first thing we do in our forward solve is align our controls to the spine. That's what we're doing. Okay, so we have that, and then the value that we're going to do is we're going to get the value. Let's get the transform of this bone, and we are going to use global space, and we are going to set this here, and this is global space. Make sure this is not a bone. Remember, we made these as controls. Okay, so now they're all in the right place, which is great. All right, and then what we're going to do is we're going to aim. Let's aim. So here we go. Aim constraint, or no, just aim. I'm not going to do an aim constraint. Let's just do an aim. And what we are going to aim is we're going to aim the ATT control at, and our target is going to be the look at control. So let's get the transform of our look at control, which is a control in this case, and it's the look at control. I think we should rename that. We will rename that in a second, and we're going to get the translation, and that is going to be our target. Okay, so compile that. Now, we do have an issue. You'll notice that our arrows are facing the wrong way, and that is because our axes are off. So we actually need to use Y forward. Right now we have X, and I know this because I'm looking at this little XYZ thing here combined with our joints, etc. So let's just change this to 0, 1, 0 and compile this, and we have that, and then we also do need to adjust our secondary. And let's take a look at our secondary axis, and what we're going to set that to is we're going to set that to 1, 0, 0. Okay, so now just that alone has made it, and I am going to make this a little bigger now. That alone has made it so that if we move this control, and actually let me compile and save real quick. If we move this control in our scene, you'll notice that all of our arrows are pointing at this control. This is why I use the arrows, because I want you all to be able to visualize this as we go. Okay, so wherever I move this is going, all these arrows are pointing at that, which is pretty cool. Okay, so Now that we have them aiming, all we need to do is we need to get all of our spine joints to align to these controls. So let's do that. So once again, I'm actually going to create a sequence for this because we are going to be modifying this. Right now, we're doing all of the controls at once, which means there's no offsets or anything. We are going to come back and be doing, we're going to be breaking this up to differentiate between the head and the neck, etc. But for now, let's just drop in a sequence. The first thing we're going to do is, actually, do we want this as a sequence? I don't want this as a sequence, actually. Reason being is, I'm somewhat skeptical at times on the order of execution with sequences. Just saying. Okay, so what we're going to do is we are going to do another for each loop. We're going to iterate through all of our stuff again. So let's go for each. But this time, as we iterate through the loop, what we're going to do is we are going to do a rotation constraint. So let's do a rotation constraint. Here it is. And what we are constraining is we're constraining the bone. So the bone is going to get constrained. Now, what's it getting constrained to? It's going to get constrained to this ATT control, the blue ones in this case. So to get that, let's go ahead and take this and concatenate, get the underbar ATT going in here. And then the parent in this case is an item. It is a control. Make sure you set this. If you don't set this to control, it will not work. Holy smokes, it freaked out. Okay, so a couple of things that we need to adjust, apparently, is, let's see, we have our maintain offset, we have our ATT, we're going through each of our joints, and I believe we probably have our character facing the wrong way. So let's see if we can take a look at what's going on with that. I know what we need to do. We need this to be not a location. We want this to be the direction. Let's see, that's one piece of it. And then the other thing is the target is a location. That is correct. Our secondary is 1. X and wait a second. This should be Z. This is flipped. Okay, so we're just trying to get these axes right. It sure does seem like our axes are flipped, y'all. So here we go. Let's remove this and take a look. Our neck ZTR is Y forward, X up, for example. So if we take a look, that's our neck. I'm just gonna use the head. Our head is flipped, interesting. Oh wait, look at this. Our ATTs are all flipped. Why would our ATTs be flipped? These should not be flipped, y'all. These need to be the same. Okay? So for whatever reason, if this happens to you, when we are making this control, when we spawn it, the initial value in global space, let's try setting this to initial. There we go. There we go. Okay, now we got it. Okay, so it's important that those are facing the same way. Otherwise, we have a built-in 90-degree offset. That's not what we want. So that solved that problem. Fantastic. Now let's go back to what we were doing. Let's see if we reconnect this, if we have our flip. We still have our flip. I want to double check something. So now our neck and our ATT, they're flipped. How are those flipped? So something is going on with our aim constraint here, or this set transform. So our setting of the transform is we are setting our ZTR, and we're setting it to the value of our bone. That should be fine. The child should go with it. And then we're aiming the child at the control with and up of Y. And I should not have to do this. But for some reason, that is flipped. Let's reconnect this in. Okay, that is what I'm expecting. There is something funky going on here. Oh, you know what? Our target? Oh, our target is wrong. That's why. 0, Let's change this to 1. I accidentally changed the wrong thing. Here we go. Okay, so now we have our axis of 1, 0, 0. This is what I'm expecting. Here we go. I was accidentally changing the target. These secondary axes matter, all right? So here we go, 0, 0, 1, 1, 0, 0. That makes me feel much better. I'm happy to continue with this demo. Otherwise, we were gonna start it all over again. So here we go. Now, you'll notice that as a result of this, we're getting all kinds of initial setups. And this is one of the reasons why I decided that we're going to do this 2 different methods, because there's something about this that I'm not super excited about. But as you can see, our character is now looking at our setup, which is great. Now, if we wanted to make this a little bit better, what we can do is, remember, this is an array. And if we look at this array, it goes from spine 1 to the head. And if all we do is take the ratio in our loop and we connect that into the weight, what happens is it basically adds in a fall off. So what's going to happen is, because the ratio, and you can see it if I print this, basically it says it right here, a float ratio from 0 for the first element to 1 for the last element. So right now, technically speaking, our bottom spine is getting 0 weight. So what we could do is we could offset it. We can take a look at that, but ultimately we're going to be changing this anyways. So now as a result of that, when we move our look at, you'll notice we get a much nicer kind of gradation fall off to our look at. Now, the thing that is a bummer about this is the default pose. The character looks like he's afraid of this little box. He's leaning backwards, and you can see it if I disconnect this. So this is the default pose, and this is where it is. I'm sorry, this is like default, no animation, no control rig. And then when we reconnect it, you can see it kind of leans back like he's afraid of this box. It's a very scary box. All right, now, so the way a lot of this is handled is the weight ratio for the spine is greatly reduced. So let's go ahead and do that, and we will go from there. So here we go. What we're going to do is we're going to split this up into 2 groups. This first group is going to be just our spine. So if I take this, if I shift click, by the way, it will expand the whole thing. I'm going to remove the head and the neck from this one. And this is going to play into the offsets that we want to do later anyways. So let's close that back up. And then I'm going to reduce this. I'm going to multiply this by, let's say, 0.2. So our spine is only getting 20% of our look at. And then I'm going to take this exact same group, I'm going to copy it, and let's come straight from our completed into here. And we'll do the same thing. I'm going to remove the spine from this one. So remove this. It's probably faster if I just come over here and I just grab the neck and the head, drag this up here, and create an item array. So make sure it's in order, neck, 1, 2, head, etc. And then for each of these, where's our for each loop? Oh, I missed our for each loop. We do need a for each loop. For each loop, we're going to be using this, and we're going to be, let's disconnect that, and we want the name. So this is going to be for our head and neck. So we can connect these in to our ATT, and then our ratio, I am not going to mess with this ratio. Oh, actually, maybe we will. Hold on. So for our ratio, what we'll do is, yeah, we can connect it in. We'll just connect it in straight. Now, what's going to happen as a result of that is you'll notice that the character lean back is greatly reduced, and it's because we've reduced the amount on the spine specifically. If I put the spine to 1, it does, or 11 actually. If I put it to 1, you'll see that very scared. But if we go to like 0.1, we get a more reasonable number. So let's just keep that at 0.2, and I think overall that's going to feel good, and our character is going to basically be looking wherever we move this to, which is cool. All right, so we do have to connect in our bones here. We're not actually connected, which is why our head wasn't tracking. So let's try that again. with our head tracking. Let's make this a little bigger so we can see how we're doing so far. So here's our look at control. Okay, that feels much better. And the cool thing about that is it does kind of lean back, and also when it goes away, it leans forward. And if we go down, oops, I missed it. Character looks down. So we've already got a nice look at working. It's actually looking pretty good so far. But there's a couple more things that we want to do to kind of just really plus it up. I'd like to make it so that there's a little bit of a lag. I mean, when people turn, they usually turn their heads first, and then the chest follows. So how might we add that in? So let's take a look at what we're going to do that. All right, so what we're going to do, and this is why I pre-built in the chest offset. So here's what we need. Let's break this up a little bit. I am going to make this a little smaller again so we can see what's going on. And what we're going to do is we have our aims. Right now they're broken up for, they're all together right now. We need to do a similar thing as we did down here by breaking up our chest. Reason being is we are going to have the head follow the look at, and we're going to have the chest follow the chest offset. And then we are going to make the chest offset lag behind a little bit. So let's start with making the chest offset lag behind. So here we go. This is our forward solve. And what we're going to do first is, actually I changed my mind. I'm going to use a sequence. And let's go ahead and drop this in here. And what we need to do is we need to get the transform. So the way that the chest offset is going to work is we're going to use some of the more physics type control rig setups. Now, depending on when this video drops relative to the physics stuff, basically we're going to add in a spring solver or a spring, which will basically make it feel like you can make any control feel like it's lagging behind, and you can control the weight of it, etc. So let's get the transform, and we're going to get the transform of the control, which is our look at control. Okay, a look at control, which we are definitely going to rename. Now, what we're ultimately going to be doing is we're going to be setting the transform of our chest offset. So the item that we're going to be doing here is a control, and it is the look at chest offset control, which fortunately we did name correctly. So here's what we're going to do. We're going to connect this in. Now, normally the way setting transforms works, you connect your straight transform in, but with a spring or Verlet or the spring there's a bunch of different ones that use physics. What you do is you kind of insert a physics node in between, and it does all of the work for you. So what we're going to do is we're going to use a spring, and I'm going to use the spring interp. Now, the target is going to be the look at control. I'm going to keep saying that because it's funny now. All right, so translate, that's going to be our target. Now, where we are currently is going to be, we're going to get the transform, and by current, I'm talking about this pin right here, okay? That is going to be the transform for our control chest offset. So what happens is, this is where we are now. This is where we want to go to. And the result of that is going to plug into our value here. Okay, so I'm going to, in order to make this show up, I'm going to steal this transform node really quickly, and I'm just going to paste this in to here. Now, technically I can disconnect this now, and I just open this and connect our result into our translation. So let's see here. So we have where we are, where we're going to spring interpolate this, and then we're going to use that to set our chest offset. So if we got that right, what should happen now in our viewport is when we move this control, you'll notice that the chest one follows behind. See the little white sphere? And that's why I made it a different color. So depending on what you set these settings to, you can really kind of exaggerate that or not. I am going to go with 2, and we'll leave that as 1. Current target velocity, that's all fine. And then when we do this, you can see there's a nice lag. Okay, so now we have this other control that is lagging behind our initial control. So what we want to do is we want all of our chest to aim at the one that's lagging, and we want all of our head and neck to aim at the one that is the snappy version of it, the main control. So that means that we need to split our loops again. So I'm just going to move this down and make some space. Let's take this entire section. I am going to duplicate it. The way we duplicate things, thankfully in Blueprint, we're going to do Control C, Control V, Control C, Control V. I'm going to paste this in, and I want to change these arrays. So this first array can be the head neck, that's fine. So I am going to, actually we're not even going to do that. Let's do this. Let's take this array and delete it, this array and delete it. Everything's going to freak out for a second, that's okay. All right, so this first one, this is our spine. All right, I'm actually gonna flop these. This is our head neck then. So here's our head neck. So that's correct. And then this is our spine. And we want to connect this from complete. And when this is complete, we want to connect this in. Okay, now, so we have our head doing what the head did before. That's what this is. This is our spine. Now, what we want to do with our spine is rather than having it aim at the head, all we need to do is update it so it aims at the chest. So let's compile that. And now what happens when we move our control, if we make this a little bit bigger, so you all can see it. When we move this control now, if I can select it, you'll notice that there's a fall off. See how the spine kind of lags behind? That's because the spine is following the white control. It's following that like light yellow control that's lagging behind. And you can exaggerate that even more just by changing your spring values. So if we come up here and we change our spring value to 1, now what'll happen is it's super slow to settle. That doesn't feel quite as natural to me, so I'm going to keep it at 2. Now, the cool thing about this is when you mouse over these settings, you might be thinking, well, what are these? The strength, if you mouse over it, it tells you. This determines how hard it will push towards the target. It's basically the speed. The thing that's interesting to understand is this critical damping. If you look at this, if it's smaller than 1, it makes the spring oscillate. So what would happen is when it gets there, it bounces back and forth. If it's equal to 1, it will hit the target and not overshoot. And if it's greater than 1, the spring is just going to take longer to get there. So I specifically set this to 1 because I want it to get there and stop. When we look at things, we don't go like this, right? Our chest doesn't do that. We just look and then our body kind of falls behind. So that's why we're going with the 1 here. So that's great. Also, I'm not a great dancer. So anyways, this is looking much better. So we've got this nice fall off and look at how natural that feels now. Like that just looks so much better. And the cool thing is when you go past the character, they're like, whoa, what just happened? Did you see that? What was that? That's great. And you can kind of like feel the life in the, like we're just playing around with this in control rig and you can just imagine, whoa, what was that? Right? Just because of the settings that we've come up with here in our control rig. So that feels pretty good so far. Okay, so compile and save, make sure everything is set, and let's see what else we've got here. So where we are right now is things are looking pretty good from an animation standpoint, which is great, but we do want to integrate this with our animation blueprint. So what we're going to do next is we're going to hop into an animation blueprint, get this set up in the blueprint and realize that we need to add a few variables, and then we'll come back to the control rig to get those all tied in and set up so that it plays nicely with the rest of our animations and we can turn it on and off when we need to. So let's hop in and take a look at what that looks like. Here we go. All right, so let's switch over to our level. And in order to test this, we're going to need a couple characters to test against. And in this particular case, I have an enemy. All the enemy is a duplicate of the third person character, but I added in these really cool eyeballs just so that we could have a better idea of which way they're facing. So we'll put these in the level. And I'm just going to vary them so we can test whether or not this is all working. And I'm going to put a couple up top and just in different positions, facing different ways. We won't go too crazy with this because this is just for testing, but it'll be fun to see how this is going. So maybe let's do one more up here. Okay, so we have our enemies, and these are going to be our look at characters that are going to be looking at us, but we need to create the BP or the animation blueprint for these characters so that we can actually connect it all up. So let's go back to our meshes folder, and I'm going to click on our mannequin, and I'm going to create an animation blueprint. This is going to be enemy look at animation blueprint. And we need to set up a couple of things in here. So let's compile and save a bunch of stuff just so we have it good to go and we can test this stuff out. All right, by default, our animation blueprint has no pose. What I want to do is I want to fill in our play idle animation, play idle. And we'll plug that in and our character should start idling. Great. Now all we need to do is plug in our control rig between. Control rig. And the control rig that we want to plug in this case is we want to plug in our method A look at. Whoops, I spelled method wrong. There we go. So now we have a control rig. If we compile and we save this and we go back to our enemy, we fill this in as our blueprint, which is going to be the look at. Our character is going to idle. And if we look at this in our level, when we walk, they're all idling, but they're all staring off into space. So what we need to do is we need to give the animation blueprint the information about where to look so that the animation blueprint can pass that on to our control rig. So in our animation blueprint, let's add a couple of variables. This one is going to be bLookAt enable. This is a Boolean. The reason I want this one is because I want to be able to decide whether or not they should even do this. For example, let's say that the enemy is going to be casting a spell, or they're reading a book, or whatever they're doing, but they're not actually looking at the player. Let's just turn it off entirely. That's one. The second one is going to be our actual position. So let's call this look at world position. And this is going to be a vector. Now this one is the one we need to do a little bit of work for. The Boolean we can just set up as a testing case, but the look at location we do need to do some work. So the work that we need to do is going to be in we have update and begin. So let's add event. And the event that I want is, let's do initialize animation. And we need the player character for right now. So let's just get the player controller. And from there, I want the controlled pawn. And with that, can we get the actor location? This is going to be our world space position. Where is the actor location? In this case, the enemies are going to be looking at the player pawn. And let's go ahead and set this to the value. Now, this doesn't always work. I'm also going to set our look at enable. Let's just enable it for testing purposes. And also need to double check our sizing here because of crashing. Make that a little easier. Anyways, so now we have that all set up. The trick is this doesn't always work. The reason being is our controller at this point may not be valid yet. So I do want to put an is valid in here. And the other thing I want to do is, now that we have it, I need to basically redo this exact same stuff down below if for some reason our controlled pawn is not valid. So let's put the controlled pawn, let's promote this to a variable. And I'm actually going to call this variable target enemy. Now, generally speaking, you would probably set this maybe in your AI tree. There's all kinds of different places, but for the purposes of testing, we just need access to the enemy. So let's take that enemy, and if the enemy, let's get this, and in this case, the target enemy, I'm going to rename this. I'm going to call this target actor. The reason I want to do that is because when it's the player for example, the enemy is different and we have enemy blueprints. So I want to be clear on this. So our target actor, I want a validated get on this. So let's set up a validated get. That just basically means all at one time I'm getting it, and is it valid or not. And then with that, this is basically happening on every time we update our animation. What we want to do is we want to be updating that position. So if it's valid, we are going to get the actor location, and we will set our lookat again to that value. Now, where this is important is if we come in here and this is not valid, then we need to redo this section again. So if it's not valid, I want to get the player control the controlled pawn, set the target actor, and then we will go ahead and actually I'm going to, just for safety, I'm going to connect in our target actor here instead. And if that's valid, then we'll plug this in. All right, that also cleans up my blueprint a little bit. Okay, so when we initialize, we're going to get our values and variables and set them, and then every time we update, we're also going to get those values as well. And then we're setting our lookat world space position. So we have our animation blueprint sort of set up. What we actually want to do is in this control rig, we want to send that information to the control rig. But the control rig doesn't have any awareness of these values yet, or even how to use them. So let's go back to control rig and let's add, this is going to be a Boolean look at enable. And let's add one more, and this is going to be our look at world space. Let's do look at location world space, for example, and this is going to be a vector. I'm going to make this a little bit bigger if I can get my mouse to work. And this is a vector. Let's compile and save that. And we need to set each of these to instance editable and expose on spawn for both of these. Instance editable, expose on spawn, compile and save. The reason we did that is because now when we go back to our enemy blueprint, if we refresh this node and then we look over here on the right, we can choose to use these as pens. So let's take and fill these in as pens. And as we do that, they pop open, or they pop up here on this control rig that we can use as an input. And we're just going to plug in our lookat and our enable. So now, theoretically, this information is being passed through to the control rig, but if we play, right now, nothing's happening. And the reason nothing's happening is because even though we're passing the information to the control rig, we're not actually using it in control rig yet. We do have a warning, which is happening here when we set our lookat. It looks like we want to make sure that the target actor is valid before we do this, which I thought this get would do. If it's not valid, we're going to get the pawn and we're going to set our target valid. All right, we'll see what that is. That's just happening because of end play. Characters are being destroyed before everything's being set up. Let's compile and save our enemies. Back to control rig. Now, what we want to do is plug in these new values. Currently, our lookat world space is being set to the bone plus a offset. Right, we have this offset in translation, so this is putting that the lookat is basically in front of our character. Now I want to make some room here because what we're going to do is we're going to plug in the idea of using the lookat world space position. So let's get the lookat world space position, and I also want this Boolean. I'm going to get the look enabled, and then I want to dynamically choose on basically construction which one we're using. So I'm going to create an if here. This if is going to get the lookat enabled, and if lookat is enabled, I want to use the world space position. If it's not enabled, then I'm going to use the default position, which is here. Let's make this a little bit smaller. so it's just easier from a spacing standpoint. So then it's going to be this one. And let's drop that in and flip these around so it's easier to read for the next person. So to recap, if lookat is enabled, I'm going to use the world lookat location, and if not, I'm going to use the default. So let's compile that. And by default, what's our lookat enabled set to? It's set to false, so that's not doing anything. If I compile this, look at how our character looks down behind them. That's because by default, the world space position is getting 0, 0, 0. Now, one other thing that is worth noting is in here, it is important to note that this is global space. This world space position is world space. World space is what the world is doing, global space is relative to the actual control rig, and then local space is relative to the parent. So just for kicks and just to be sure, I'm going to put in a from world here, which is going to convert this to the global space. That way we have it in the correct space for this rig. I want to take this section and this let's take all that. I'm going to copy this for right now. So we're setting our position, that's great. That's happening in construction. Now we need to do a similar thing down here in our forward solve, because what I want is in our forward solve, before we set our transforms, I would like to set the position of those transforms. So I've got this sequence. I'm going to move this pin down. And what we want to do is let's set this world space position. Or no. Let's set a transform. Set the transform. Set the transform. And the transform we want to set is for our look at. It should be this look at control. Okay. So in here we'll pick control, make sure we get the right type, and it's going to be our look at control. Let's use look at control world space. And did I use that? Is that what I'm setting up here, just to double check? Yes, look at control world space. So these match. All right, so back down here, we're setting our look at control world space, and the look at control is a child of that, so it's going to be in the same place, so that's going to work. And we are going to change this slightly. And we're actually going to use a boolean. So a proper boolean in this case, or branch. So if we're looking at that enabled, then what I want to do is, if that's true, I'm going to feed in, and let's just temporarily dump a transform in here so that it'll set up the pin and connect in our translation. Okay, so we have the control, the world space, our look at enabled. If it's enabled, we are going to set that, which should update this position and put us in the right zone. So let's compile and save that. By default, when we grab our control, everything still works in control rig, so we didn't break anything there. We should be getting all of our positions piped in. Interestingly, these guys are not actually looking at us. So what is happening is either our values are not valid, or our enemies or our characters aren't valid. Let's see, are we using the right blueprint? We are using the right animation blueprint. And in our animation blueprint on update, basically it's invalid. It comes here. Let's go ahead and actually our look at should be enabled. So in our anim graph, we have the control rig. It should be enabled. Let's just double check by doing a quick draw to see where it thinks it's looking in game. So we're getting the target actor. So let's draw a debug sphere to troubleshoot this. The position is going to be where our character is. Size is 35, duration 0.1, thickness of 2, and let's just hop into our match. Okay, so they think they are looking at the right place, which is great. But what is happening is somehow either we're not getting that information properly in our control rig, or for example, our look at enable is not correct. So our look at enable is set to false, but this should be instance editable and on spawn. Let me just set this to true for a second here. And then let's just see if that does it. Okay, so that's not the problem either. And then let's double check. So if it's true, we should be getting the world, look at world space, and feed that into the look at in global space. And that is the control, okay? And we're doing the same thing up here. Look at world space, global space. If our look at is enabled, we're getting that value. And let's just double check that we're not accidentally resetting it. Let's just plug this straight in and see. Just double check. So we're setting the transform for the control in global space. We're getting it from the world to global space. We're not messing with initial. I do think, okay, compile and save. Let's play. Okay, they're looking at us. All right, we found it. All right, now they're looking at us. It's kind of cool to see them following us. There's a couple things that I'm not positive on, so let's just double check a couple things. All we did was remove the Boolean. So this Boolean look at enable, for some reason, is not evaluating to true. Let's just connect that back in and see. Yeah, they're not looking at us. So something's going on with our Boolean value actually. Okay, let's try one more thing. Let's set this to true just by clicking on it. Look at that. Okay, so something is going on with our Boolean variable in the animation blueprint. This look at enable seems to be strange. It's almost like it's not true. It's clearly set default value is false, but you know what? Just to be safe, let's set it to true here. Let's go back to our anim graph. Should be there, compile and save, and let's play. Interesting. Oh, actually, what might be happening here, I have an idea of what's happening. This could be airing out because our player controller, yeah, okay. That's what was happening. So what's happening is this set look at enable was not getting set because our player controller is not valid when this starts. So we're never even coming in here. So this test that we're doing down here to check to see if our target actor is valid, the only reason it's working at all is because we're coming through here, we're setting our target actor, and then we're getting the location. Now we're actually setting the look at enable as true. So what we would need to do is we would need to make sure that whatever ultimately we end up using to set this look at enable, that it is actually valid, which is important. Okay, now when we run around, dude, this is it. We're there. Okay, when we run around, it's so cool to look up here and see these guys tracking me as I go around these corners and stuff. It just makes them feel like they're connecting. Now, they're looking down a little bit. You'll notice when I'm standing right next to this guy, they're looking straight at it's actually looking at the center of the capsule. So what we can do is when we set our look at location, we could account for that. We could get fancy. We could get the character, we could get the root bone, the head bone, whatever. But for the purposes of the demo, let's just add a value to this. We're going to add 100 in Z, for example, and think of this as now that character is looking at our character's head, for example. 100's a little high for this character. It looks like they're looking over our heads. So let's say 80. Actually, let's do 88. And the reason I'm picking 88 is that is the capsule half height. That's pretty good. That's good enough. Ultimately, you may want to get the character's head. It depends on where you want them looking. But I think that does it. Let's fix this one error. we're getting the set look at world space graph, target actor, trying to read excess none, trying to read property of target actor, look at world space. So that is here. It is weird to me that we're setting it. We're coming in here. If it's valid, we're setting it. And then we're still getting this error again. I don't like the idea of a double valid, but let's just do it. See if that solves our problem. We would change the order of this. Okay, compile and save. Let's play. Everything should still be as it was, but when we escape, we still have errors, different errors this time. Setting the target actor. You have got to be kidding me. It's almost like this validated get. Oh no, it's not. Okay. Wow. All right, what's happening is when we're ending the game, all this stuff is being destroyed. So here's what we're going to do. We're not going to have to do the double. Let's just see if this is valid. So if this is valid, then we will continue on to do that. And I'm going to remove this check by doing that. See if we clean that up. Everybody's still looking at me? That's great. No errors. Perfect. Okay, so to recap real quick, and again, this is a little bit more about the animation blueprints and less about the control rig, but basically as that was getting destroyed, our character wasn't, our player controller wasn't valid anymore, so it was still trying to come through here and get the positions. What's important to understand though is you can't rely on this update blueprint initialization. Whatever your mechanism is for your experience or game to make sure that this character is valid, or whether you're setting it in the enemy AI trees, wherever you happen to be setting it, make sure that that is actually a valid position. One last thing to potentially check is if we uncheck, I think we already checked this, if we uncheck true, are they looking where they should be? Yes, perfect. So what is that checking? By unchecking look enabled, what we are doing is we are making sure that this portion of our control rig is evaluated properly, so that if we aren't using the look at enable, what we're actually doing is we are using that position that's about 100 units in front of our character's head, and by default we could check this off, I believe, and that would make this a little bit easier to test in Blueprint. And then when we play, they're still looking at us though, so because everything's connected up properly now. Great. Now what might be fun is to see what this looks like if our characters are running. So let's go back here and go to our Anim Blueprint, and inside of our Anim graph, let's get the jog, I believe it is. No, run, play. Let's just see what this looks like if our characters are running. Do they still look at us as we travel around the map? So here we are, they're running. Look at that. So what's happening is they are, if you take a look, they're still running. The animation looks good. And as they're running, they're looking at me. So we're testing the running case as well. So this is gonna work really well for a lot of cases without necessarily completely destroying all of our animation, and we get our look at, and that's because we're fading that up the spine. You can control your fades, you can control all those kinds of things. Another thing to note is, in addition to look at enable here, you may want to give yourself an alpha, so you can just completely blend it off over time depending on what your setup is. In our particular case, I'm not going to worry about that. And in our control rig, we do have our look at enable set to false now, so that we can continue to test in control rig now that everything's working as far as our setup is concerned. So I'm going to compile and save everything and get this all prepped for Patreon. But that actually wraps up our control rig video. This is method 1, or method A. We've managed to actually tie our enemies and NPCs. That look at gives us that extra connection to the player, which I think feels pretty good. And actually, as you saw with the run and the idle, it does so in a pretty cool non-destructive way. Maybe if you have weapons, you may need to add in a little bit of IK to this, depending on what it is that you're doing, or exclude the arms, etc. You'll have to dial it in for your use case, but overall, this was a lot of fun, And it's a great example of how we can use control rig to bring our experiences to life, or add that extra little bit of verisimilitude to our experiences. That is the only fancy English word I remember, and it, for those of you that are new to English or etc., it just means believability. It just adds in that connection. So, as always, comments, feedback is welcome. Feel free to throw those down in the comments down below. And also a huge shout out to our community. Thanks for supporting the channel. Thanks for being part of this adventure. Hopefully, we'll see you in an upcoming live stream. Don't forget to check out the live streams. A lot of our content is there. My name's Kevin. See you on the next one. Take it easy.